Hey, everybody. Thanks so much for joining us. Good morning, good afternoon, good evening, wherever you are in the world. Thank you so much for tuning in to ethglobal.tv and for joining us for the Superchain chat. So my name is Jacob. I help uh, lead partnerships here on the ETH Global team. And yeah, really excited to invite you to one of our summits around Superhack. So Superhack is our hackathon for the Superchain. It's our second iteration of this event, and it wraps up at the end of next week. But we wanted to put together a couple great conferences or summits for you over the weeks of the hackathon, and today is no different. So for all of you tuning in, you're watching this probably on ethglobal.tv. This is our platform for all the different conferences and streams and summits and things that we do here at ETH Global. And there's a shared chat there. Feel free to log in, make your profile, and then have a conversation on the side. And we'll be watching this stream for any questions that you have as well. Cool. So for anybody joining us who's not familiar with who we are ETH Global, and we have one very simple mission, which is to onboard thousands of developers into the Web3 ecosystem. And we do this primarily through two different means. So we do this with hackathons, and we do this with summits. So Superhack is a hackathon that has almost 1,000 people building from around the world on top of the Superchain. We run about 15 different hackathons a year, both in person and online. And then we also run another dozen or so summits. So today we're focused on the summit aspect, and we'll be chatting about the superchain. So we wanted to put together a couple handful of talks about what the important things that are happening in the superchain ecosystem are. And we wanted to bring on both the people who are kind of researching and working through these topics, some of the people who are implementing these, and also some of the different contributors that are actively growing the superchain. So really excited for our chats today. Just as a kind of quick preview for the next couple of hours, we're going to kick off with a chat around Superchain interoperability. We're going to have Mark and Zane from the OP Labs team come and share about the roadmap around interoperability and the kind of promise that that's going to bring to the Superchain ecosystem. We're going to have a chat with Jonas and myself about why the Superchain is the best home for builders, really focused on the retro funding aspect and some of the exciting work that's happening on the OP collective side. We're going to have a chat with Luca from L2Beat about fault-proof systems. Of course, Optimism Collective recently rolled out and approved the fault proofs within the ecosystem. So Luca's going to do a whole overview of what that means for the OP ecosystem and also how that contributes to just the general tapestry of fault-proof research. And then finally, we're going to wrap this up with an exciting chat around why the Superchain is the best home for chains. So that's going to be with Ian from the Tools for Humanity team or WorldCoin team, and Sophia from the Celo team. So both two chains that are building on top of the OP stack and possibly joining the Superchain. So those are our four chats for today, and hoping that you stick around and join us for the entire time. So yeah, without further ado, we have Mark and Zane, both from the Optimism team, to come and chat about interoperability. So we'll welcome them onto the stage. Hey Zane, hey Mark.
Hey, good afternoon, good evening, good morning.
Good to see you both.
Hey,
Awesome.
yeah, thanks for having us.
Well, yeah, I mean, really excited for this one. I know that interoperability is one of those really key stated goals for the superchain. So yeah, excited to learn more about how that research and how that work is going. And yeah, without further ado, I'll let you two take it away.
Amazing. Thanks so much, Jacob. So why are we even talking about interoperability? So the rollup centric roadmap for Ethereum, we're doing a phenomenal job of scaling Ethereum, right? So this is from L2Beat, but you can see, rollups are doing around 100 TPS today. Now, what that affords us, right, with subcent transactions is increasing the accessibility for decentralized compute for a variety of different actors, whether you're using it for payments or DeFi or sharing your art on chain. Now, however, this proliferation of L2s has created an accessibility issue, right? So this is a nice tweet from Vitalik saying, hey, moving across different L2s like OP mainnet to base, it's fragmented, it's hard, right? Even moving things like USDC, if I have USDC on OP mainnet, why can't I just use it on Zora to mint an NFT? Now, this pain exists today because L2s, whether it's OP mainnet or base or Arbitrum, the only way they communicate with each other securely is via L1, right? So we have that 7-day wait time to go from an L2 today back to L1 and then redeposit into the other L2. So how does interop solve this? Interop provides secure highways for L2s to securely communicate with each other. So instead of having to go through L1, OP mainnet can communicate directly with base can connect with LISC, and so on and so forth. Now, the question is, once this is launched early next year, what does this afford application developers to do? So going back to that pain point, right, that today using Ethereum is a fragmented experience, we expect application developers to integrate native interop directly to end bridging as we know it today, right? So instead of having to bridge your USDC from your source chain to whatever application you're using, you'll be able to use any balance from any chain on the Superchain to interact with the application that you're working with today. So with that, all that context, how does interop work? I'm going to pass it over to Mark to talk a little bit about that.
Hey, so this is really the big problem statement that we're trying to solve, right? The superchain needs to feel like one chain, right? We need to get to a world where users focus all of their time and energy on, doing the thing that they actually want to do rather than, managing what chain their assets are on or switching their RPC, right? It needs to be one button press, do the thing you want to do. Cool. Can you go to the next slide? So we're gonna spend a moment. We're just gonna put on our archaeology hat here, right? Because they say that computer science is more of an archaeology thing. Like all the problems have already been solved. And yeah, next slide. Okay, so here we are. We're in some ancient ruins. Kind of mysterious. Let's like explore around a little bit more. Oh wow. Okay, we found a treasure chest. Okay, let's open this up. Oh wow, designing data intensive applications. This is some ancient wisdom from the computer scientists around how to develop actually scalable applications. And it's like we forgot about this wisdom in the Web3 world because our infrastructure just doesn't horizontally scale yet. And this book is about horizontally scalable services in this microservice architecture, right? So we need to kind of learn from, the Web 2 world because they were able to scale, infrastructure to the globe and have, millions, billions of users. And we're getting there. This interop is the first step in adopting this sort of architecture and this sort of thinking. So, right. And we want to think about interoperability from a product perspective. Shout out to Zane doing an amazing job, bringing that product perspective. I've learned so much from him. He's amazing. And basically the idea is, interoperability itself is not a product. The product is secure, portable, fungible ERC20 tokens, right? If you're just able to send messages between chains, that doesn't really matter. It's really, being able to send tokens between chains. So that's kind of like what we're focusing on as like the first use case of interoperability.
Thanks, Mark. And just want to flag one thing. I think from the user perspective, we talked around, hey, this is going to abstract the pain points of bridging and network switching. But from the application developer standpoint, why would someone want to integrate this? It's going to help them reach users that they typically wouldn't be able to do, right? So if our goal is to build the next internet scale application, we're going to not be able to convert our top of funnel if users have to go use another application and then come back and use my application once I have my assets. By integrating native interoperability directly and being able to tap into any asset across any chain in the superchain, we expect application developers who integrate interop to perform better than those that don't because of that ability to tap into that liquidity.
Totally. So we're working on a standard called Superchain ERC20, and it's a simple extension to the ERC20 standard that we know and love. And basically what it allows for is, cross-chain portability and fungibility within the superchain. And we're working on making sure that all of the tokens that have been deposited through L1 to L2 can, migrate seamlessly to be able to use this new standard. So everyone asks us, what about XERC20? Why are you introducing a new standard, right? So really, our interoperability solution is 100% compatible with XERC20. If you really want to, have your token native to many ecosystems, XERC20 is a great, tool for you. We are big believers in, building a generic low-level infrastructure that can support, many different types of tokens and abstractions. And we believe that ultimately, intent-based systems will build on top and provide like a seamless user experience, and users won't even know, what interoperability protocol they're actually, using under the hood. Cool. So now let's take a look at interoperability from the perspective of secure message passing. So this is like the low level kind of details, right? We have design philosophy is very important when thinking about systems. So basically our design philosophy here is we want to take a minimal diff approach. And GeoHot taught us this. And this is actually worked out really well for us because so many teams are able to, implement the optimism patch into their code base without it being a huge headache. And this is how we're able to have, OP-Geth, OP-Reth, there's an OP-Besu out there, there's OP-Nethermind, there's OP-Aragon, and shout out to all the teams that are doing amazing work, maintaining all these different clients. So minimal diff. And then we also want to be flexible and make sure that we just work with existing applications. We don't want to, have to add like a giant burden to integrate with interoperability. It should just work. And we also want to make it simple to reason about. So we'll start off with a little bit of vocab. So basically we have this idea of a dependency set. And this is the set of chains that you can accept inbound messages from. So every chain defines its own dependency set. And then we have this idea of an initiating message and an executing message. And this is kind of, the initiating message and the executing message together make up the full cross-chain message. And the initiating message is the information on like the source chain that ultimately gets pulled into the destination chain, and the destination chain can consume that information. Okay, Zane, you want to cover this?
Yeah, totally. So I think, as Mark alluded to, right, this is the lowest level abstraction. So there's going to be two transactions, very similar if you all have used Circle's CCTP, two transactions to send an asset or data across chain. That is not the best user experience. So that's why we're actively working with teams like Across and Hyperlane to abstract some of this from the end user. So when the application developer goes to use it, potentially they can use the lowest level abstraction, and the user would have to navigate these two transactions, one of which could be abstracted with like a relay or a paymaster, or it can be completely abstracted through the use of third-party tooling like Across, Hyperlane, where the user just signs one transaction and the asset moves seamlessly across chain.
Cool. So like I said before, we have this idea of a dependency set. Every chain can define their own dependency set. The chain operator is able to add or remove chains. And this is a unidirectional relationship. So you can just, define a dependency on a chain and just start accepting inbound messages from that chain. Okay, so Let's talk about the initiating message, right? So the low-level primitive in this interoperability scheme is the log, right? This is like emitting an event in Solidity, right? So the superpower that is unlocked here is that you can emit an event in Solidity, and then that same event, you can basically import it into another chain. So you can read events of remote chains. So what's nice about this is that any log can be an initiating message, right? So all, existing smart contracts, they already emit logs. Logs are already a widely used tool. Tooling supports it, indexers support it. So this ties back to our philosophy of making it just work, right? If your application is already emitting logs, that means that other applications on remote chains will instantly be able to start, ingesting those logs and reading them and acting based on them. Okay, so now we have the executing message, right? So the executing message is what ends up on the destination chain, right? And this is the one invariant. If you really want to understand how the interoperability protocol works, is we have this executing message invariant where every executing message must be valid, meaning that the initiating message, because an executing message is a tuple, right? It's a tuple of an initiating message and an identifier. So on the remote chain, when you want to, teleport a log from a source chain to a destination chain, right? This is like the remote chain. You basically send this executing message, right? And it's made up of this identifier and the initiating message, so the log. And the blockchain enforces that every identifier uniquely or correctly references the log that was also passed in, right? So what does that mean? What does correctly mean, right? So this identifier basically points to a log, right? And we have all this information to uniquely identify a log. We have a chain ID. So it's basically saying, this log that we're processing came from this chain with this chain ID. And it was in this block number, and it was located in this log index, right? So that those three properties are all the information that you need to uniquely point to and reference a log across any chain in the superchain. And the blockchain software, the full node, is able to, hold this invariant that every single time that there's a cross-chain message, there's this executing message, part of the cross-chain message, it tallies up all these executing messages and enforces this invariant that all the executing messages are valid, meaning that the log that is passed in the message matches its identifier.
Cool. So one note here. So while our initial focus on interop is abstracting bridging, I think this design that Mark is walking through opens up a new space for experimentation for novel primitives. For example, things like Oracle chains, using attestation data on one chain in a smart contract in another. So we're very excited, yes, to abstract bridging, but then also introduce a new tool set for developers to start experimenting with decentralized compute.
Totally. And I think that's a good example. Like, really quickly, if let's just say we have an Oracle chain, and basically what this flow would look like is there's a chain, Oracle updates are just pushed to it. And every single time that there's an Oracle update, it emits an event, right? Now, anybody can just take that event that was emitted and basically create an identifier for that event. So they create this pointer to it, and then they basically pass it to another chain. And that's what it would look like. You can basically, pass the Oracle updates and broadcast them across all the chains in the superchain. Cool. So some key properties here. We have this shared proof system. We have this like change to the fork choice rule. We have no force inclusion. And like I said before, like all the applications that use events are now automatically interop enabled. And we have this cool property where the more sophisticated block builders are, the more throughput we can get, the more scalability we can get with interoperability. So the reason why shared proof system is really important is because it decreases the platform risk, right? Like we want the superchain to be like this trustworthy platform that developers can build on, sort of like, people, build their applications into AWS and they're able to use all the services that AWS provides, and AWS just keeps running, and your application isn't gonna like, all of a sudden stop working on AWS. And then we have this shared single proof system that's shared between all the chains. And the idea is that this, is really what allows for the fungibility of all the assets, right? Because if you don't have the same security model between all the chains that you're interoperating with, then you have to be careful of having this weakest link sort of security model. And go on, Zane.
I was going to say, this shared security model is such a superpower. If you guys have used like the Cosmos ecosystem before, they've done a phenomenal job. But one of the pain points I've had as a user is like, I don't know what's going to happen once I send my asset from, let's say, Osmosis to another chain in the Cosmos ecosystem. The cool thing about everyone within the Superchain being on the same software version, sharing the same proof system, is I know that, between 2 seconds and a few minutes, that asset or that piece of data is going to respond, and that the chain on the other side is governed from the same security model as OP mainnet. So what that means is that the user experience is consistent, and I don't have to worry about waiting hours for my asset to arrive or something like that.
Nice. Yeah, totally. So okay, so we also have like this guarantee of message integrity, right? Like there's no way for a message to be, fraudulent or to be faked. This is like one kind of common thing where people are like, oh, like, what if, the sequencer is able to fake a message? This cannot happen. Because of this simple guarantee around the, executing message and the invariant, because like when you reason from invariance, the reality is like in blockchains, everything is invariance and state machines. And if you just think of it in terms of invariance and state machines, you're good because you can, reason about your systems that are really complicated in a simple way. So as long as we hold this invariant about the executing message being valid, and if there's an invalid executing message in a block, that block is invalid. It's reorged out of the chain. So what this means is that your applications don't need to worry about any sort of faked messages being sent around the superchain. You can just, assume that you're getting valid messages and leave it up to like the full node software to reorg out bad messages. We also have this property of no force inclusion. So what does this mean? We're big believers in simplicity. So like a lot of people ask like, oh, like if I send an initiating message on one chain, that's literally just emitting an event. Like, does it, force include, does the protocol force the executing message to like happen? And that's not the case. Like Zane mentioned before, it's 2 user transactions. And we think that, relayers or solvers will play a big role in just making it 1 user transaction. So it has nice user experience. But we get these nice properties without force inclusion. Like you don't need to have awareness of the remote chain's gas. You don't need an inbound message queue. You don't have these like really tight synchrony and timing assumptions between all the chains. Like you could imagine like this crazy sort of attack where, all the chains in the super chain decide to send tons and tons of messages all to the same chain at the same time. Like, how does that happen? Right. So we don't have to worry about that because we don't have in protocol force inclusion. Um, you know, and it's simple to reason about because of that. Cool. And like I said before, backwards compatible. Existing applications already use logs. You're, emitting logs in your application probably today. You can start producing data for other, applications on other chains. And then, builder sophistication, this is like a little bit of a, MEV in the weeds kind of thing, but it is possible to have atomic cross-chain transactions. If the same block builder, the same sequencer is building blocks for multiple chains, you can have cross-chain callbacks built on top of this protocol. This is not like a feature that we're, striving to support as part of the first release, but this just is about the simplicity of the protocol. It's like really flexible to build a lot of cool things on top. And yeah, you can kind of think of this as like, at the lowest level, it's like broadcast UDP. You emit an event. That event can be, pulled into any other chain that's interoperable. And then on top of this, low level abstraction, we can build, higher level abstractions that enforce things like, domain binding and replay protection. Cool. So let's talk about contributing because, contributing is really important. We're working in the public. Our specs, you can go to specs.optimism.io, or on GitHub, you can go to, Ethereum-optimism/specs, see all of our work, our roadmap and our tickets. They're all on GitHub. You can see how we're progressing. If you want to come contribute, come say hi. We have a contributor Discord. Come hang out with us, jam on how to scale Ethereum. If you want to come join our Discord, come say hi on GitHub, comment on a ticket here or there, and we'll notice you. And then, we'll see that you're serious about contributing, and we'd love to have you.
Cool. And I just want to give a shout out. Interop is not being built just by OP Labs. This is a collaborative ship alongside core contributors like Wonderland, Base, Agora, as well as a variety of different ecosystem partners like Across and Hyperlane, to name a few. So we're excited to bring this to market over these next couple of months. I think the last thing to share is public DevNet is coming soon. Keep following Optimism on X or Farcaster. Follow the OP Stack channel, and we'll give everyone an update when you'll be able to come play with the public DevNet, test out some of that message passing that we talked about.
Amazing.
Is that my cue?
Amazing. Yeah.
Awesome. Well, thank you both. Yeah, I really appreciate you, jumping through that presentation with us. And I mean, in particular, this is a piece of the Superchain roadmap that I'm, really excited about. I guess I had a kind of quick question, or maybe not quick, actually. It depends on how deep you want to answer this question. There already is, you kind of highlighted some of these bridges or I maybe classify them as like more like third-party type applications that, developers can use today to have some version of interoperability. I guess curious about like, where do you think the balance is between the network implementing some kind of more network level interoperability, like as in kind of what we just discussed on the Superchain side, versus like just putting that up to like developers in the ecosystem? Like where's that like balance between like we've pushed too much into the network versus like we completely like leave this up to developers to figure out?
Yeah, if we can bring up the screen share again, that'd be super helpful. So I think a big part of Optimism's ethos is minimal diff, like Mark talked about, building in the open, and then also building with other contributors in the ecosystem. So the way I like to think about native interoperability, and that's if you look at the red in this diagram, we're providing the tools for the application layer interops like the layer zeros, the hyperlanes, acrosses to improve the economics and latency and security of their underlying protocols. So very specifically, right, if you want to move an asset using a cross between OP mainnet and base, whether you're the across LP or the across solver, you don't have good tooling today to move messages securely between these two chains. And we are now providing, as the protocol, the primitive required for them to prove the security, latency, and economics of them. What that means for the end user is today, if you want to move, let's say, 100 USDC from OP mainnet to base, you're going to have to pay around 5 bips just because of like the capital costs and latency of the existing solutions on the market. When we've modeled out with Across, based on this low latency message passing, we're able to bring that 5 bips down, that take rate down from 5 bips to 0.02 bips. What that means is there is a world where the take rate for moving assets across chain is cheaper than even gas. And what we expect to happen, right, when we bring down that cost is that application developers, they have an incentive now to integrate it because that cost is so nominal for end users where they're saying, hey, I'm willing to do this to use your application. So to summarize, we are not building native interop in a silo. We are working with core contributors on the protocol, as well as working with infrastructure players like Layer Zero, like Across, to integrate this into their respective product with the ultimate goal of bringing down costs for end users and improving the latency across the board for cross-chain interactions. Mark, anything you want to add?
Yeah, I think that's a really good response. You covered it really well, and I think, yeah, it's really about, doing what we can to make it easier for, these application or these service providers like Across, Hyperlane, Layer Zero to easily plug in and then provide a standard interface. And in the ideal world, users have no idea of what is happening under the hood. It's literally just one button, and maybe it's a little cheaper, maybe it's a little more expensive, depending on the route that you're going. But yeah, this should all be abstracted away and just result in a nice user experience across the entire Ethereum ecosystem.
Super dope. Yeah, I think that stuck out to me in this presentation for sure. It's like the amount of times that you said that users should not be aware of the standards that are happening under the hood. Like, I could not agree more. I mean, all of this work is like in service to the end user, ultimately, right? And like whether it's using XERC20 under the hood or some other standard or like, yeah, like I mean, like who cares, right? You don't know if you're using TCP or HTTP. Like none of these things matter if you're an end user, right? So, yeah, really, really cool. Awesome.
Totally. It's time to build applications that solve problems for users. And, we are ready for the users to come, use blockchains. And, I'm really excited to see what everyone is going to build.
Likewise. Awesome. Well, thank you so much both for your time and for your hard work here. And yeah, as I mentioned, all this is happening in public. So if you have any kind of strong opinions about this, or you want to get involved, or you want to just kind of understand the roadmap, it's all there for you to take a look at. So thank you so much again, Zane and Mark, for coming on today.
Thanks, Jacob.
Thank you.
Best of luck, everyone. Cheers.
Awesome. Well, thank you so much. We're going to kind of transition now into why the Superchain is the best home for builders. So I'm actually going to join this chat with Jonas. So Jonas is the head of retro funding at Optimism Foundation, and we're really excited to have Jonas joining us today. So welcome to the stage, Jonas. I think you're muted.
What's up, Jacob? Nice to be here.
Yeah, awesome. Well, yeah, great to see you. I mean, for context to the audience, I mean, we'll jump into what retro funding is too, but I don't just have a role at ETH Global, but I also do play a role in the Optimism Collective as a badge holder citizen, as well as a delegate, actually. So I'm going to be speaking both from a curious outside observer, but also somebody who is actually voting on some of these proposals and thinking about these questions. So yeah, just wanted to make sure that the audience is aware of that too. But yeah, I mean, maybe kind of just as a place to start, I mean, let's just kind of start from scratch. Like maybe Jonas, if you could share a little bit more about, retro funding. And when I put together this talk, I was, thinking about like retro funding being such an additive feature of the Optimism Collective and building on the OP, on on the OP stack or building on the Superchain. So yeah, can you maybe share a little bit more about kind of the history of like what got us here and maybe just what retro funding is?
Sure. I can tell you a bit about the lore that got us here. So many years ago, before optimism was optimism, it started as this thing called Plasma Group. And Plasma Group was this collective dedicated to scaling Ethereum via the scaling solution called Plasma. And they were doing all the hard work. I think this must have been like 2018, 19, this type of time frame. All the hard work to doing research on how to best scale Ethereum, many Plasma implementations, much progress, but they were obviously still early on. I mean, we're still figuring out the scaling problem. But they had some promising progress, but ran into this roadblock of a lack of public goods funding. So Plasma Group got some grants from different ecosystems, but that was not sufficient grant funding to keep them alive. And they realized they also were not able to raise venture funding or similar because there was no business model behind scaling Ethereum. And so Plasma Group evolved into this thing called Optimism. And one of the core visions, ideas behind Optimism is to solve that public goods funding problem. Something like scaling Ethereum should be at the heart of Ethereum, and so there should be like a lot of motivation to solve it, and also like a lot of support in terms of funding and rewards for solving it. And this is where retroactive public goods funding comes in. It's this idea that at Optimism, we are dedicating a lot of the OP tokens, and we're taking some of the network revenue to spend it on the public goods which support the network. And we do it retroactively with the idea that instead of trying to predict what will be useful in the future, we are able to like look back in the past and all agree on the contributions that made Optimism great. That's kind of the TLDR on the lore of how we got here.
Love it. Yeah, I do have like some very positive memories associated with, Ben and Jing and Carl at like past ETH Global events, 2018, 2019, scalability like that was such a top of mind thing even back then. So it's amazing to see like how this has all kind of evolved into this crazy collective and optimism and the fact that like, hey, this thing's like actually working. Like, we have sub-cent transactions. Like, yes, it's been an amazing journey to witness. I guess you mentioned that retro funding is sort of flipping the funding model a bit in the sense that you're kind of retroactively funding things that have worked that you can already see work. I guess, looking back at some of the rounds now, what are some of the kind of maybe unexpected outcomes or outcomes that you've seen that you were excited about over the last few rounds?
Yes, it's so the general idea, or it seems counterintuitive, right? Like, why would we go back and give rewards to the people that have already done the thing? And we want to reward people based on the impact they have created. So how useful was their contribution? And in some cases, you might say if their contribution was very useful, they might have already received rewards for this. So why do you give them additional rewards? It seems really weird. And the idea behind retro funding is that if we constantly reward people for the contributions that they've made, we kind of create this predictable, almost market-like model where you know that if you contribute to Optimism, you will be rewarded in future retro funding rounds. What we found in like the rounds is that it's actually harder than we thought. So when we started off, we were like, it's easier to agree on what was useful in the past rather than like to predict stuff. And then we realized there's actually like a lot of energy in trying to like measure and document who made what contribution in the past and how useful it was. I think really one of the coolest moments that we had in the early rounds that we did was round 3. So that happened in the beginning of this year. Time flies. And we really saw this like huge round. It was like 30 million OP tokens. We had like around 750 applicants, and really everybody that you know and love within the Ethereum ecosystem got rewarded for their contribution to optimism. And this was across everything from the core Ethereum research and development work to developer tooling to people building applications and more. It was like this big celebration of optimism and Ethereum. And that was just a very nice moment to witness. It had like a lot of positive energy.
Yeah, totally. Yeah, I've been, I think, a badge holder since the second round. And it was crazy to see. Basically, it almost was like a 10x from round two to round three in terms of the number of projects and just like the amount of like impact that got rewarded, I think. So that was like particularly cool to see as like a badge holder. It meant a lot more work, and we can kind of talk about that in a second. But I kind of relish that work in a way because it's like, how often do you get to just like do a job, quote unquote, where like your whole responsibility is just helping give back like rewards to people who have like done great things. Maybe before we get to kind of some of the iterations in the rounds and how you're addressing the scalability within our retro funding, but maybe just before we jump into that, like one of the adages or one of the kind of defining um, uh, words around kind of retro funding is this adage of like impact equals profit, right? And I think you maybe alluded to this, like, we thought it would be really easy to reward people retroactively for their work, but I think what we found is that it's been very difficult to like define these terms, right? Impact and profit, right? Like I think it's surprisingly difficult to do both of these. So I guess curious about, first of all, like what does the impact equals profit mean to you? And also like how are you thinking about the shape of things that cause impact to the optimism ecosystem and the shape of things that equal profit?
Totally. Impact equals profit is this idea that if you provide impact to optimism, you should be rewarded with an equal amount of profit. So we want to make sure that like in the end game of this thing, we really want to make sure that each person that has contributed to the collective is like rewarded fairly for what they added, the impact that they had. And what this means is we try to measure in a bunch of different ways how people have advanced optimism. What we found in doing these rounds is if we make the kind of problem statement clearer, that helps us in doing that. So in the first 3 rounds that we've done, we had this very general scope where we said anybody can apply for their contribution to optimism. And then we try to make sense of all these like wildly different types of contributions. And now what we've done in the beginning of this year is transition the program to like theme-specific rounds. And that brings a lot more clarity to people. So we just closed off the on-chain builder round, which was all about rewarding people that deployed their own contracts on the Superchain for the activity that they've driven. So for the gas fees they generated, for the users they're onboarded, etc. And for the rest of the year, we're looking at 3 different rounds to come online. The next one is dedicated to the OP stack. So all the core contributors there, all the research and development, governance. So all the people that make optimism governance great and all the tooling and infrastructure, data analytics that goes into it. And then developer tooling, all the things that help developers build great on-chain applications. And posing it as like these specific questions makes it much easier for everybody to look at and say, this builder has driven this much activity on optimism, rather than we have like this very abstract way of looking at it.
Gotcha. Super cool. Yeah, and in case no one else kind of cued into this theme, if you look at the Superhack prizes that Optimism is giving out, they are directly aligned on OP stack, governance, and developer tooling. So not only would you, if you win a Superhack prize from Optimism, get actually some advanced funding, you would also qualify probably your project for the retro funding round that happens later. So that's a tip for all the builders watching. Yeah, you mentioned this kind of like change from the first couple rounds, the first 3 rounds being more kind of broad and general, and then kind of now this like theme-based approach. You also like have changed up like big aspects of the rounds. Like, round 3 introduced like the concept of lists. Round 4 was basically like you're voting on all the projects and you're just kind of selecting which like aspects of on-chain you think are like the most important and how you weight those things. Like these are like huge iterations. I know one of the kind of foundational principles is to like iterate and see how things are going and adapt. Like how do you make sure that like those iterations are like in the right direction, or like how do you make sure that like how are you measuring these things basically, because they feel like huge changes, which is exciting, but like how can you make sure that like that's tending towards like the right outcome long term?
Totally. When Optimism started with its governance, when the Optimism Collective was introduced, we had the strong motto of saying this governance will self-destruct, because we knew we're not going to get it right on the first try. So we must be able to essentially make radical changes, kill what we've done before, pivot to get this right. And these systems are like so abstract in a sense, and they're very like dependent on human behavior. So it's incredibly hard to also model them, formally model them and make good assumptions about them. And so the challenge behind retrofunding is really iterating towards that goal of rewarding impact accurately. How we know if we're getting it right or if we're getting it wrong is by listening to the citizens. And we've even become better at, and I think there's even like a meta game of the iteration where we don't only iterate and improve the mechanism, but we also learn how we iterate better, which is quite fun. So a bit of background, right? Like the Optimism governance is made up of the token house. So this is all the OP token holders, and you have delegates there who shape a lot of the economic policies. They do proactive grant giving. They vote on protocol upgrades. And then you have the Citizens House. And the Citizens House is quite a novel idea of saying we want individual Optimism citizens there, and we want them to have we want it to be a one person, one vote kind of democratic body. And the Citizens House is responsible for retrofunding, and that's and Jacob, you live in both houses, so you know both worlds. And we really know if what we're doing goes in the right or wrong direction by listening to citizens. So we've written like incredibly long reports on like round 3 and round 2 of what we learned. In round 4, we got a bit better about getting like broader input through surveys. So we asked people things like, do you feel like this round is an active improvement in the design choices that we've made? What do you not like about the design? What iterations should we make for the future? So the Citizens House is really like the governing body, and over time, and they really decide on the reward allocations. And over time, we hope this becomes a thing where the foundation steps back from a role of actively shaping it, and we can really give it all over to the citizens. But yeah, curious, Jacob, if like you've been on for a wild ride. You said like round 2 and round 3 were like very intense in terms of the time and consideration you had to spend. What has your experience been like of just being a citizen participating in these rounds?
Yeah, I think it's been very interesting. I would say that, yeah. So yeah, to highlight like round 2 and round 3, I think for round 3, like I probably spent 20 hours or so, like actually going through every project. And like, I guess it became more of a time commitment than I expected initially, but I think that is also, like I said, like it's something I actually enjoyed doing because it's like cool, like, this is like an amazing way to like overview like what impact is like transpiring in the ecosystem. So I thought it was just like a great overview, but definitely took a decent amount of time. I was basically super impressed slash like shocked by how little time like round 4 took for me, I guess. Like I think for that it was like an hour and a half because, it fundamentally like changed the way of like how we're thinking about this. Like basically like the decision in round 3 was there was like 2 decisions to make. Decision 1 was like, is this like valid impact? And then like how much profit should they get? Right? Like I always had to make 2 decisions. Right? In the 4th round, like in a way, like the decision was just like, hey, like these are all on-chain metrics, right? So it's like, first of all, it can't be gamed, right? Like it's just sort of like, this is like what the chain is telling you is happening on the impact side. And you just had to decide sort of, given all this data that the team has kind of put together for all these different projects in the round, like what are the aspects of on-chain data that you decide is impact, basically. So you weren't deciding like, was the project having impact? You were actually deciding like, does it matter how many unique active addresses like use this protocol? Does it matter like the TVL of like that protocol? I actually don't know if that was one, but that type of like shape of things, right? Where it's like, how do you measure like impact? And I thought that was like, that was super interesting. And it also just made it a lot easier because I didn't have to review. I think it was probably 200 or 300 projects in that round, but it was, I just had to review like what of the 20 or so different metrics that were available to me as a badge holder I thought were valued, as well as just like, should there be a multiplier for like open source software? And like, I think that like that thought process was like much easier to reason about, and also in a way like it's a little bit more democratic, right? Because it's just like I'm not thinking about individual projects anymore, and not thinking about like, hey, like what is this doing? I'm just thinking about like what does impact mean, right? And I thought that was super interesting. So I appreciated both like the time savings there, but also like the thoughtfulness and the types of metrics that you had brought up within that context. And yeah, I thought it was super helpful. And also like I see that as like a clear way to help scale this thing, because definitely like after round three, my biggest question was like, what does scalability look like in this system? And I know the on-chain side like makes that super easy. I'm curious about how you'll do things for like developer tools down the road, because you might not have those same like metrics available to you, but nonetheless, I thought it was like super interesting.
Yeah, with round three, we kind of reached this like local maxima of like we
That's
know
how I
like
felt. Yeah.
yeah, it's like we know we can't like push this further. We kind of reached the max of what we can do here. Good to hear that you liked the round four experience. I think the biggest feedback we got on that was like more human touch would be valuable. So I think that's something we want to look at, is like how can we still give some like match to like purely on-chain data, like with subjective human input, and like combine the best of both worlds. The overall idea came from Carl from Open Source Observer, of saying the voters, the citizens of Optimism, are not citizens because they know each project on Optimism super well, but because they care about the ecosystem health and setting the right incentives. And so this is like the types of questions we want to ask people, like what type of behavior or impact do you want to reward? What does that look like, etc. And I hope we get to, or not, but I think there will be many more on-chain builder rounds. And I think that's the exciting part, is we always get back to iterating, making it better. And we're really looking forward to make this a more reliable experience for builders. So that really, if you build your application on Optimism and you build this beautiful interop powered Superchain app, you will be rewarded for driving the adoption, onboarding new users, driving gas fees, etc. I think we've made like a lot of progress this year towards getting there, and hopefully by like mid next year, we're really in like a space where we can really give the guidance and credible commitments to builders that they can rely on this program more.
Super cool. Yeah, I mean, I could totally imagine like at least that most recent round, like the on-chain builders round, like that feels like a format that you could like more like you could easily sort of like divide that by 12 and do it like once a month, and just like set the on-chain like parameters, like it's between this and this, and like literally like even month to month, my like badge holder vote like wouldn't even need to change, because I'm just deciding like what the impact of those on-chain metrics matter for me. And I could see that being like hugely like predictable source of revenue for projects that are like building public goods, if that were to like happen. So very cool. I guess curious about like that aspect of, this year you sort of announced all the rounds up until the end of the year. Maybe there'll be some secret rounds, but I guess like do you worry a little bit about having those themed rounds announced like 6 months in advance, like changing the way that people think about this, or the incentive mechanisms? Because I could also imagine like in a way you could see people arbitraging that type of situation. So I guess curious, like what are you seeing, or what are you thinking about on that side?
We really want to make this reliable for builders. And that is why we pre-announce the rounds, so they know this is coming up. Like going back to the Plasma Group example, if we had Plasma Group today and they wanted to build scaling, they wanted to scale by contributing to the OP stack, what they would need as a group of people spending their full time on this is a really reliable way to understand how they're gonna pay the bills, right? And maybe they even wanted to raise like venture funding in the expectation of getting enough revenue to pay the bills and more. And if I look at the Plasma groups today, we really have to give them this reliability and they can't really run a business around like a round popping up out of nowhere. And so that's the idea of like pre-announcing the rounds, is give more predictability to builders, and make this really a repeated game, rather than like thinking of this as like a one-off round type thing. We want to build it so that this round will happen over and over again until the end of time, right? That's too.
Very cool. Okay, cool. Yeah, totally makes sense. I mean, I think that predictability is like super key, and like that's the main thing to optimize for. And like, yeah, I think that makes perfect sense. I'm gonna maybe jump into a couple of questions about like just like the builder aspect. Like, if I'm a builder right now, I keep hearing about this like retro funding thing. Like, I guess like maybe I'll do like a quick round of questions. Like, do I apply? Do I not apply? Like, how does this work? Like, if I built a project at Superhack and it's focused on, it's like an OP stack chain or whatever. Like, do I qualify for retro funding even if it's just a hackathon project? Like, does it have to be business? How does that work?
If you build an on-chain application and you see some traction, we have minimum criteria. You should definitely apply for the on-chain build around. If you're hacking on the OP stack, and you really take the time and effort to develop a mod or make similar contributions that are more like long lasting, you should definitely think about applying. Similar for developer tooling. If you are the one that's making smart wallets or an easy onboarding happen, and you're helping your fellow builders with what you're building there, you should definitely apply. It's very like round over round. We have specific rules and criteria. So like a shameless plug here is go to retrofunding.optimism.io. And so you can sign up there with your Forecaster account, and then you will be kept in the loop on the upcoming rounds. You see what's happening throughout the rest of the year. And then there will hopefully be a round for you if you're building on the Superchain.
Sweet. Do I have to build on the Superchain? Like, if I like built something really dope and it's like it works on Ethereum too, like does that disqualify me normally? Like, how does that work?
Doesn't. If it works on Ethereum too, that's totally fine. The main point we care about is like you're building something that's useful to the Optimism collective, to Optimism builders, to users, etc. So that's really the thing that matters to us. Everything, and we care about open source. You're definitely not excluded if you're not building open source, but there's always like a strong emphasis on builders that license open source. But yeah, we're not like saying you have to be exclusive. You have to be in an exclusive relationship with the Superchain. Just matters how you improve optimism.
Gotcha. And I mean, just for completion's sake, you've announced the rounds for the rest of the year. But like, let's say I just missed the on-chain builders round, like, is it too late? Will I ever get rewarded again? Like, what do you think is going to happen there?
It's over. It's so over.
So over, yeah. You missed it by a month.
There will be another on-chain builder round next year, and the impact you have now on Optimism on the Superchain, that will be rewarded in the next round. So if you have contracts now and people are using them, you've built something useful, that information will be relevant for rewarding you in the next round. So that's kind of the beauty of it. Even if you missed a past round, you're not missing out because what you're doing right now will be relevant for the next one.
Awesome. I think it's sweet. Cool. I mean, I think that maybe answers all the common builder questions that I see. I'm trying to think. But yeah, I think the main thing to take away is what Jonas said, which is like, if you're building something that, improves the lives of or impacts the collective in any way, and you're building it and it's available to all to use, it's very likely you'll qualify for a round either now or in the future, or one of the upcoming rounds or one of the upcoming unannounced rounds, right? I think, the goal here is like there is a giant set of tokens allocated to this exact thing, right? Yeah, I think I think that's a good note to wrap up on. I don't know if you have any like last questions for me, as this is kind of like a badge holder therapy session in some way.
Any round you're the most excited about for the rest of the year?
I think I'm actually most excited for probably two that stick out to me. One is like the OP Stack round, and one is the dev tooling round. The OP Stack round, it sticks out to me mostly from like I think possibly like an entertainment purpose. I would say like OP Stack can be used in like such a variety of like wacky ways that I'm like just excited to see like what experiments are happening on the OP Stack side and how people are like leveraging like just like a set of modular tools to like build interesting L3s or app chains or like tooling around that aspect. So I'm like excited about that just because I think it's going to be wacky and fun. And then I think on the dev tooling side, I mean, I've always had a personal interest in dev tooling as a dev myself, and like one of the reasons why we were so excited about starting ETH Global at the beginning was just like so impossible to build things on blockchains in 2017. It's gotten way better, right? But I think there's tons of like tooling that is still there, and we see a lot of great dev tooling projects come out of our events, and I think it's super exciting to like run around that's completely focused on just making it easier for other devs to build. Just because that's like from my point of view, that's like an accelerant type round where it's like if that round really pops off and people are excited about that and continue building better and better tools, like further rounds that have nothing to do with dev tooling gets better too. So yeah, I'm excited for those two, and yeah, I think I filled out the form to remain in the Citizen House and continue being a part of this iterative process. So I'm very excited for this.
Awesome. Yeah, me too. Personally, I'm also very excited about the dev tooling round, specifically because we will try to do something similar to the on-chain build round of measuring
Very cool.
the like usefulness impact of dev tooling well. It is tricky though, but it's always fun. It's always fun to work on these rounds, get people's input, feedback,
Yep.
get beaten down and get up to the next one to make the system better.
Well, yeah, let us know if we can be helpful at all as ETH Global with sharing some of the tooling that we see builders using today.
Cool. Maybe at some point a retro funding related hackathon.
Could be
Could
fun.
be a thing.
Could be fun. You know where to find me. Awesome. Okay. Well, thank you so
Cool.
much, Jonas. I really appreciate you joining us.
Awesome. Till next time. Happy hacking.
Cheers. Thanks so much, Jonas, and have a great weekend. Okay. Awesome. Well, yeah, thank you again to Jonas for joining us today and sharing his thoughts on retro funding and why the Superchain is basically the best place for builders to be building because they get rewarded retroactively for everything that they do. So yeah, I mean, really excited to jump into our next chat, which is featuring Luca from L2Beat. Luca wrote this amazing Notion doc recently about the fault proof wars and just sort of jumping through all the different systems. And as you may have heard, like Optimism recently shipped a big upgrade around fault proofs. So we're gonna have Luca join us to kind of chat about all these different systems, the Optimism system, along with all the kind of other systems that are in the space, and do a great kind of overview of what fault proofs mean for network security. So welcome to the stage, Luca.
Hello. Hey everyone. Thanks for having me. So again, I'm Luca. I do research at Altbit. We've started looking into fraud proofs recently because it's the first time that we actually see some live protocols on mainnet, live fault proofs protocols that work in a permissionless matter with the release of Optimism fault proofs. So like we have taken this opportunity to study fault proofs better, to try to come up with a proper mental model on how to assess the risks of, or the trade-offs of the systems. And I'm currently writing an article. There is this Notion page that I'm sharing around for feedback. But the goal here is to, again, analyze different fault-proof systems. There are three main companies building fault proofs: Optimism, Arbitrum, and Cartesi. As it turns out, all of them have different trade-offs, different approaches, and it's interesting to see indeed what these different approaches are. And it's cool. Like we want to discuss these things because one thing that we noticed is that usually teams don't talk with each other, like they don't know what the other teams are like building. But what we think is that teams should really like look into each other code or systems we really encourage, like, this is, my controversial take maybe, but I think teams should really like copy each other in a way. It's, this game that we're playing is positive sum, I think. So, and also, as a way for users to better understand what's going on when using a system. So first of all, what is a fault-proof system? The idea is we want to let the L1 know about the L2 state. So we need to publish something that represents the state on L1. And also we want to validate the state on L1. We want to prove to L1 the state is correct. There are two ways, as we all know, to do it. Either with Ziki proofs, in which you prove that a state, the next L2 state is valid with a cryptographic proof, or you use an optimistic approach in which you publish state roots, and if those state roots are not challenged, they are accepted as valid by default. And the only way to not accept a state root as valid is to challenge them. So in optimistic protocols, we use a challenge protocol to basically prove that something is incorrect. The thing is, the trivial way to prove that something is incorrect is by re-executing everything, right? So you have a state transition and you reapply the state transition on L1 for very complex computations, like a full, universal virtual machine like the EVM. This is not really feasible, or it's very complex. There are some upchains that do this, like Fuel V1. They have a fault-proof system that is permissionless, but is single round, meaning that they basically re-execute everything between two state transitions. But this is possible only because their state transition function is very, very simple. Optimism tried to do this with OVM, but as it turns out, it's like very, very complex. And it's better to use something that we call a bisection game. And a bisection game is something that allows fault-proof systems to reduce the space of execution that needs to be re-executed on L1. So instead of re-executing the full state transition, we try to find a way to reduce the space and just re-execute something very, very small, possibly even one single instruction. How can we restrict the space? The trivial way to do this is as follows. It's using a linear search. So we have initial state. Everyone agrees on this initial state. Also, everyone agrees on state transition function, of course. And then we want to propose a new state root after 1024 steps, let's say. But again, as we said, we cannot re-execute these 1024 steps because the assumption is that this is not feasible because the virtual machine, the state transition function is too complex. So we start this interactive game. The malicious asserter has proposed a malicious state root, a state root that is not correct. A challenger can ask the asserter to publish on L1 the state root after one step. And if both the asserter and the challenger agree on the state after one step, there's no need to re-execute the step on L1, right? So if they agree already on the first step, then the challenger can ask for the second one. And maybe they agree on that as well. Then it can ask for the next one. This until it finds the first state for which, after one step, it disagrees with. So in this case, it's in between 934 and 135. 934 is the one that both agree on. And the next one is the one that they both, like the challenger disagrees with. And now, given two states, the only thing that you need to do on L1 is to re-execute this single step. And L1 can then decide whether the asserter was right in asserting these 935 steps or not. And then, eventually slash and continue with the protocol. The thing is that this is a linear search. In the worst case, you need to ask for all the intermediate state roots, which is, in the worst case, again, a number of state roots that is the same as the number of steps. And the complexity of doing this is almost the same as re-executing everything. So we want to do something that is smarter than a linear search. And what we do is a binary search. So I will not go into the details of this, but what can be done is instead we can ask for the state that is in the middle of the execution trace, in between two state roots. So we ask for the one in the middle. If we agree on this mid state, then we know, like, we agree on the mid state, but we disagree on the final state. So we need to find the instruction can be found in the second half of the execution trace. So we restrict the space by, we divide the space by 2, basically, in just one step. And we can continue doing this over and over recursively. And by doing this, we can find a single instruction of disagreement that we need to re-execute on chain in a logarithmic number of steps, of communication steps. And when we found, again, this single instruction of disagreement, there is an on-chain one-step executor that is in the form of a minimal VM, usually. It could be, minimal RISC-V. Optimism uses MIPS, but it also plans to use other virtual machines for redundancy. Or it could be WASM, also in Arbiter. So before going to this slide, the way that we thought about fault proofs initially was that we want the system to be able to be protected by just one single actor. And because, even if there are many malicious actors that are proposing malicious state roots, we want to be able to defend the chain with just one single honest challenger. This challenger will just challenge all the state roots, will win eventually. And then the correct state root will be finalized, will be settled on L1. The thing is that this is not really correct. It's not really a 1 out of n assumption, this single honest challenger assumption, but it's more a function. It turns out that it's more a function of fans that the attacker has. And I can explain this with this example. So imagine a fault-proof system without bonds at all. The only cost in the protocol is performing the bisection game, the challenge protocol, the single final step on chain. So like the only cost that we have is gas cost. If there is only one honest challenger, there is one simple attack that can be done. And this attack is a ton of malicious asserters propose a ton of malicious state roots. And the honest challenger has to attack all of them, has to challenge all of them. And as we said, a single challenge, a single bisection game has a gas cost. And if the malicious attacker, if the attacker has more funds than the honest challenger, it can win by what we call an exhaustion attack. Basically, it wins by exhausting the resources of the honest challenger. A protocol like this is safe only if the honest challenger has more funds than the attacker in aggregate. So it's not really 1 out of n, like it's not any actor that can protect the chain. This actor also needs to have more funds than the attacker to safely protect the protocol. So it's better to think about the assumption as a function of the attacker funds instead of just, a simple 1 out of n. But, this is a protocol without bonds. The only cost is gas cost, as we said. Let's add the bonds and let's see what happens. So there are 2 ways that you can set up your fault-proof system. And this is really important for, a protocol designer. The first way to do it is with full concurrency. And full concurrency means that all the challenges happen in parallel. So you have a fixed challenge period, let's say 7 days. And in these 7 days, there could be a lot of malicious state roots, invalid state roots that you need to challenge. And you, as the honest challenger, you need to perform all these challenges at the same time. So if you have bonds, you need to stake bonds to propose a state root, and you need to stake bonds also to challenge state roots, because like if there is a malicious challenger, you also place a cost on the honest asserter. So there has to be a cost in both proposing and challenging. So let's say that both proposing and challenging has a bond, a stake. If you need to challenge many different state roots at the same time, you need many bonds. So you kind of get the same exhaustion attack as before. Like adding bonds here doesn't really help with exhaustion attacks. The other way to do it is with partial concurrency. You say actors can only participate in one challenge at a time. If it needs to perform multiple challenges, the challenges are placed one after the other. And for each challenge, you have 7 days. And the downside of this is that, of course, if you have many invalid state roots, then finalization is really delayed, because like you need to perform one round in 7 days, then the next round in another 7 days, depending on the number of invalid state roots. But the advantage of partial concurrency is that you only need one bond to protect the chain. So you stake one bond, you perform a challenge, you win, and it's only one challenge because again it's partial concurrency. When you win, you get the funds of the malicious actor because you win and you slash and take the funds. So now you have even more funds than before to play the next challenge protocol. So like you need only the bonds to play one challenge to fully protect the chain. The downside is again delay attacks, what are called delay attacks. But we will discuss it, this attack in a moment. We will discuss the attack in the Arbitrum Classic protocol. Arbitrum foolproof system, this live today on mainnet, uses partial concurrency. So one actor can only perform one challenge at a time. Each challenge takes 7 days. And the way that it works is sort of as a graph in which instead of just challengers challenging state roots, challengers are also required to propose an alternative. And by proposing an alternative, challenges happen between state roots, kind of. So in this case, an honest asserter proposes state 2048. A malicious asserter proposes an alternative state at after 2048 steps. And then a challenge can begin between these two state roots. And then you can place bonds. Every state root depends on the previous one, on the validity of the previous one. So like they need to wait for the previous one to be confirmed, for the next one to be confirmed. Also, you can move bonds between state roots and so on. The thing is, this is partially concurrent, as we said before. So this protocol is affected by delay attacks, and we will see a practical example in a moment. One problem that you have in fault-proof system that you need to deal with is invalid bisections. So as we said before, when we were discussing the bisection game, you as a challenger, you need to ask for the midpoint. And then continue this game by repeatedly asking for midpoints until you find the single instruction of disagreement. The thing is that even if you propose the correct state root, and then someone challenges me, I can publish a midpoint that is invalid. So even if I proposed a valid state root in the beginning, I can then publish an invalid midpoint. So I said here, a malicious actor can propose correctly and bisect incorrectly. And this is a big problem in fault-proof system because it means that when someone loses a challenge, you don't really know if the state root at the beginning was valid or not, because it could be that the state root at the beginning was valid, but the only thing that happened is that the actor started to bisect incorrectly eventually, and then it loses because of this. And one can use this kind of problem to perform delay attack on the current Arbitrum Classic protocol. And the way that it works is that you have a malicious asserter that stakes on an invalid state root. Then you also have a lot of other malicious asserters staking on the correct one instead. And then what happens is that since this is a single actor and the protocol is partial concurrent, these challenges happen one after the other. And every challenge, again, is 7 days. And if this malicious asserter manages to match first the malicious confederates, and these malicious confederates will try to lose on purpose by bisecting incorrectly, and will do this as slowly as possible to waste the full 7 days. The protocol, like this attack, induces a delay, a 7 days delay for each malicious asserter. And by doing this, of course, they're burning stakes. Like when you lose, you always lose a stake. But you could have an incentive for which, it makes sense for you to burn stakes to delay the protocol because, I don't know, you're shorting the protocol token or whatever. There could be an economic, incentive to delay the protocol. And this is the delay attack on the current Arbitrum Classic protocol. Arbitrum is developing a new fault-proof system to solve this issue. And the way that they solve this right now on mainnet is by having a whitelist, basically. Not everyone can propose state roots. Not everyone can challenge state roots. This whitelist is kind of small. And so the maximum delay is capped effectively, but also all the members in the whitelist are kind of known. Altobit is one of them, by the way. So like there's not really an incentive to attack the protocol, but we want to have permissionless full-proof system eventually, right? So Arbitrum is building a new full-proof system, which is called Bold. And the way that they solve this issue is by preventing invalid bisections at all. Like in Bold, they're impossible. And the way they do this is that when you propose a state root, you not only propose a state root, but you also propose what is called the history commitment. So you take all the intermediate state roots, you create a Merkle tree of all these intermediate state roots, and then you also publish the root of this tree, which is called an execution history commitment. Then when you want to bisect, when you want to publish the midpoint, you need to prove that this midpoint is included in the execution history commitment. And in this way, it's impossible to bisect correctly. Like if the execution history commitment is correct, it's impossible to bisect it correctly. And now, since it's possible to bisect it correctly, anyone can bisect for you. Like even if you propose the correct valid state root with a valid execution history commitments and someone challenges you, you can go offline and someone else can resume your game because like the protocol guarantees that it's possible to, like it's impossible for the state root to lose, basically. And also it uses share nodes in the sense that multiple challenges share the same nodes, in the sense that, if you need to bisect from state 8 to state 4, you would do this multiple times in multiple challenges. So like there is a smart way to make the protocol more efficient by sharing nodes. So in Arbitrum Bold, it's impossible to bisect it correctly by using execution history commitments, and they use share nodes to make the protocol more efficient. And in this way, they can use full concurrency. They can use full concurrency because also honest parties can pool funds together, since again it's impossible to make a valid state root, a valid assertion lose. So anyone can pool funds and play the game together, basically. So given this cost efficiency, the protocol could be made fully concurrent. The problem with execution history commitments is that usually the number of steps that you have is huge, like 2 to the 60. And given 2 to the 60 steps, you need to calculate 2 to the 60 intermediate state roots. And just computing one state root is a huge amount of work, usually. And computing 2 to the 60 intermediate state roots to build this execution history commitment is pretty expensive. So the way that they solve it is by using a multi-level protocol. And the way that it works is that instead of committing your execution history for all the steps, you take bigger chunks and you just commit these bigger chunks. And when you go into the bisection and you reach a point in which you're in between two chunks, what you do is that you repeat the full protocol again, So again, like here, let's say that you have 2 to the 30 steps, but you cannot build this huge tree. So you take chunks of 2 to the 10. Once you reach two chunks that are close together, you basically repeat the full protocol, but one level down, in the sense that you now take smaller chunks together. And then you can build, how many levels that you want, basically. Bold uses 3 levels, but the thing is that there is a downside in using levels. And the downside is in resource exhaustion attacks. Like adding levels to a protocol induces resource exhaustion attacks. So let's think again about the single level, which is this one. So let's say again, we commit to the full execution history without levels. You can design the protocols so that you calculate you only need to stake once, because it's only there is only one possible correct state root with one possible correct execution history commitment. So you need just to stake once. You can pull funds together, and for each challenge there is a gas cost, of course, but you can design bonds such that the bond size is a multiple of the gas cost of performing one challenge. And in this way, you just need, let's say that bonds are 10 times the cost of performing one challenge. It means that the attacker, to win by performing a resource exhaustion attacks, needs to have 10 times the resources of the defenders, because you perform the challenge, it costs, I don't know, 1 ETH, but to induce 1 ETH of gas cost to the honest parties, you need to stake 10 ETH. And this 10 ETH is a bond that you will lose because you will get slashed. And the honest asserters will win those bonds. So again, to induce 1 ETH of cost to the honest parties, you need to stake 10 ETH. And we call this resource ratio. And in this case, the resource ratio is of 10, because the attacker needs 10 times more funds than the honest parties. And this is better, of course, than a protocol without bonds. The problem with levels is that levels induce resource exhaustion attacks where we get, again, a resource ratio of 1. And this can be explained with this slide. So imagine that you you're at the first level. The honest actors propose one state root. You have multiple invalid state roots. So this kind of works. So imagine that bonds are 10 ETH, and the cost of performing one challenge, the gas cost is 1 ETH, as we said. So the resource ratio here is, in theory, 10. The problem is, every time you reach the single step, a level 1, you need to repeat the full protocol a level 2. And when you repeat the protocol, of course, the honest actors has to stake some bonds again. And the attacker, by placing 4 bonds, can induce 4 subgames. And those 4 subgames induce 4 bonds from the honest actors. So 10, 10, 10, 10 bonds, which is 40 bonds from the attacker, induce 40 bonds from the honest actors. And in this way, the attacker can win by having more funds. If the attacker has more funds than the honest actor, it can win with a resource exhaustion attack. The way to solve this is by also scaling bonds. So when you go down one level, you want your bonds to be scale down by your desired resource ratio. So if the bonds here are 10 ETH, the bonds on the lower level need to be 1 ETH to preserve the resource ratio of 10. So in this way, each 10 ETH bond only induces 1 ETH bond for the honest actor at the lower level. And you need to repeat this for each level. So if you want to have more level and you think it upside down, every time you go up, you need to multiply your bonds by your desired resource ratio. In this case, if you have 3 levels and the cost of performing one bisection game is, let's say 0.1 ETH, which is, much greater than this, but, for the sake of argument, 0.1 ETH, you need to say that your bonds at level 3 are 1 ETH, and then at level 2 are 10 ETH, and then at level 1 are 100 ETH. So like the bond sizes with multi-levels are very big. And indeed, in bold, I can give you some number. The top assertion bond is actually 3,600 ETH. So to propose one valid stateroot, you need $10 million. Like this is huge. And then when you go down, it's 555, and at the third level is 79. If you calculate the ratio, this is around kind of close to 15%, which means that like honest actors need 15% of the funds of the attackers to protect the chain. But as you see, the bond sizes are huge in this case. And the clocks are, they use a challenge period of 7 days. Then we have the Cortese protocol. The Cortese protocol takes the opposite approach. Instead of having a fully concurrent protocol, they use partial concurrency. So like challenges are played one after the other, but they use something more clever than the Arbitrum Classic protocol, which is a tournament, which means that you have brackets, and actors in this challenge protocol play in this bracket tournament, and the advantage is that the delay is not linear in the number of malicious actors, but only logarithmic, because by having this bracket tournament, it's very likely that malicious actors will play against each other, and eventually one of them needs to lose. And of course, the brackets are played in parallel because this is fine. So to cause every bond that the attacker stakes and loses will all induce, as I said, a logarithmic number of delay, which is very nice. Cortese also uses execution history commitments as in bold, but in this case they're necessary. And again, execution history commitments are needed to prevent invalid bisections. And preventing invalid bisections also allows people to play together within only one stateroot, because the stateroot cannot lose by bisecting correctly, right? And this is necessary because otherwise you would need to have multiple honest actors playing independently in the tournament, because they cannot trust each other, since one of them, even if they propose correctly the first assertion, they could bisect incorrectly. So everyone needs to play for their own, basically. But the problem is that eventually 2 honest actors can be matched together, and in this case we don't know what to do. When 2 honest actors are matched together, we cannot eliminate one, because it could be that the one that wins then starts to play incorrectly, starts to bisect incorrectly. So preventing invalid bisections is a requirement for a tournament style fault-proof system. And to give some numbers here as well, they also use 7 days challenge period of 7 days. The bond size is 1 ETH, so it's much, much smaller than what is used in Arbitrum Bold. And the resource ratio is not really a ratio, because as I said, it's logarithmic. It's better to talk about resource functions now rather than resource ratios. So I will not go into the details, but since they use execution history commitments, they have the same problem of that it is too resource intensive to calculate this commitment. So they also use levels, and they have the same problem that as in bold, in which each level can induce additional stakes because you need to repeat the protocol again. In Cartesi, in the Cartesi protocol, this is not really a problem because like you don't need to scale down your stakes because n bonds at the top level only induce a logarithmic number of challenges at the lower level because again, this is a bracket tournament. You will match dishonest players only a logarithmic number of time, and so you will have only a logarithmic number of games at the lower level. So you don't really need to scale down your bonds, which is different than in bold. Like in bold, every attacker, like every invalid state root produces one game at the lower level. And here there is some math to show that actually the delay for multiple when playing with multiple levels is huge. If you do the simple math, with 8 Sybils, 8 invalid state roots, you can induce a delay of 4 years. Because, like, again, I'm not going into the details of this, but as it turns out, the math tells us that the delay with multiple levels is actually exponential. So you don't have this issue that you need to scale bonds in Cartesi, but you get this issue that the delay is huge. So like with 8 Sybils again, and only 91 bonds, which is 91 ETH, you can delay the protocol, the finalization of state roots by 4 years. The way to solve this is to use only one level. And to use only one levels, you either use less steps or you prove only one bigger steps. And Cartesi is thinking about using Zika proofs to like instead of just executing one single step on an on-chain VM, they want to use Zika proof to prove a bigger computation. And by the way, you can also do like hybrid protocols in principle when you do a Cartesi style tournament, but instead of being a binary bracket tournament like this, you can have bold style tournaments with a cap number of players playing in parallel, and then when they finish, you go to the next bracket in the tournament. So instead of this helps because instead of just being the delay just being a logarithmic of base 2, in this case becomes a logarithmic of base 8, which is better, of course. But this to say that there are interesting ways to combine these protocols. So going to the optimism protocol. The optimism protocol is interesting because it doesn't use execution history commitments at all to prevent invalid bisections. But the thing is that while execution history commitments have the advantage of allowing honest actors to play together, the optimism protocol does this even without execution history commitments. And the way that they do this is instead of placing a bond for each proposal, for each state root, you need to place a bond for each move that you make into the protocol. So you want to bisect, you place a bond. You need to bisect again, you place another bond. And when you attack, you're basically attacking moves inside the protocol. So it could be, since they don't use execution history commitments, it could be that someone starts to bisect incorrectly a valid state root, but then you can kind of challenge this move again. And since every move has its own bond, this is safe to use in a shared setting because what are slashed are single moves. So this allows the protocol to, to have multiple honest actors that play together, that challenge, invalid moves. But what's also very interesting is how the bond size is managed. So to give some numbers for the optimism foolproof system, one interesting thing is that they don't use 7-day clocks. So the challenge period is not 7 days, but 3.5. So half of what the other protocol uses. But the real advantage of placing bonds for each move is that just taking, because if you only have top level bonds, you need to have a bond size that covers the cost of the full bisection game. But in this way, you can have very small bonds that only cover the cost of one bisection. Yes, one bisection step. So proposing one state root in the optimism foolproof system is 0.08 ETH. And this is super small. Of course, this number is wrong. It's not $10 million. It's much smaller. But the thing is that every time you go deeper in the bisection game, the bonds that you need to stake grows exponentially with a factor of 1.09. And if you do the math with the depth that you can have in a bisection game in optimism foolproof system, the actual total to perform a full bisection game is around $2 million, which is kind of in the same order of magnitude as in the Arbitrum Bold. But the thing is that in the happy case, just propose one state root is super cheap. So like the protocol can remain live with very small bonds. There is a very high cost in protecting the chain, basically. The thing is that, what about the resource exhaustion attacks? Since you need to, what is the resource ratio? Since to perform a bisection costs more than proposing state root, it means that one attacker can perform the attack that we've seen in the beginning, which is this one. You can have an asserter that proposes a lot of malicious state roots, and all of them have 0.08 bonds. And the honest challenger has to attack all of them. But the point is that the move to attack costs more than the cost of proposing malicious state roots. So actually, optimism foolproof system slightly favors the attacker. But this is, it can be argued that this is fine because honest actors can play together, can defend the chain together. Like the amount of funds that you need to protect the chain can be pulled from multiple actors, and these actors are guaranteed to profit eventually. Like you can only perform resource exhaustion attacks during the attack, but honest actors are guaranteed to profit. So it is reasonable to think that a lot of people will join because there is a guaranteed profit eventually. What about the challenge period? So as we said, why is the challenge period 7 days usually? And I will not go into the details because I'm running out of time, but the main reason is strong censorship. So there are two forms of censorship, weak censorship and strong censorship. And strong censorship is when transactions cannot land on L1 at all on Ethereum. They're completely censored. They're not even delayed, they're completely censored. And this can happen if the testers that are, those actors that vote on the head of the chain, there is a malicious majority that always votes for alternative blocks that never include your transaction. And if you're an honest challenger, you want to challenge a state root, but you're getting censored, the only way to resolve from this is with a hard fork. We need to coordinate on hard fork on Ethereum to slash manually the censoring actors. And we usually say that we need the community kind of agreed that we need 7 days to coordinate a hard fork. So that's why the challenge period is usually 7 days. Optimism uses 3.5 days. So like it's not clear whether 3.5 days is enough time to protect from a strong censorship attack. So to conclude this presentation, why are we even discussing fault proofs here? Why are we potentially wasting so much time trying to analyze these protocols if we have ZK? Initially, we thought that building optimistic rollups was much easier than building ZK rollups. It turns out that this is not really true in the sense that we, very recently got the first fault-proof system live on mainnet with Optimism. That is permissionless and universal. But we already have some ZK VMs already. So like, why are we building optimistic rollups? And the reason, my answer to this is that I think we need to think big. We need to think bigger in the sense that there are some kind of computations that are not possible with ZK. Like the throughput of a chain of a ZK rollup is capped by how fast you can prove transactions. Like you cannot process more transactions than the ones that you can prove, because otherwise you would increasingly fall behind the head of the chain with your proofs. And there's always some cost in proving as well, and some time cost as well. But with an optimistic rollup, you don't need to prove anything in the happy case. And so you could really have optimistic rollups with super huge computations that are only, kind of proven on L1 in case of challenge, but you don't even prove the full computation, but only, a small part, as we've seen with the second games. So the way that I would answer this question is optimistic rollups allow for rollups that perform really, really complex and big computations with really high throughputs that is not possible with ZK. And I think we should, thrive to do that. We should go through this direction. If you instead you're building a simple EVM within the usual gas limits, I don't think there is any reason of going into the complexity and trade-offs of channel protocols. But again, I think we need to think bigger.
Awesome.
And that's it.
Great. Yeah. Thank you so much, Luca. I really appreciate walking through all of this with us and really doing so in depth. I think, this is like, as you said, like a very interesting place of research that, first of all, like not everyone is working on it or like kind of sharing all these insights together. And I think that like when you have somebody in the community that is like understanding all kind of three of these systems at the same time really well, it helps sort of be the bridge between different implementations. So I really appreciate what you're doing and appreciate you being here to walk through the presentation with us.
Thank you.
Awesome. Thank you so much, Luca. And great, we're kind of moving on to our final chat from the Superchain chats. So we're going to be welcoming Ian and Sophia to the stage. So Ian is from Tools for Humanity, which is one of the teams that is helping build WorldCoin. And then Sophia is head of DevRel for the Celo chain. So yeah, excited to have them both on stage. So welcome them up. Hello, folks. There we go.
Hello.
Hello.
Oh, that's so funny you both said that.
There you go. Good to see you both. I know we saw each other last night in person, so it's great to be in here on virtually connected. Yeah, I mean, I think the reason why I wanted to have this chat about why the Superchain is the best home for chains is, both the ecosystems that you both are working for, the Celo ecosystem and the WorldCoin ecosystem, are both kind of on their own independent journeys towards, implementing OP Stack into their ecosystem, and then in the case of WorldCoin, kind of joining the Superchain as well. So, I mean, maybe kind of to jump in on that point, maybe Ian kind of, or maybe we'll start with Sophia, actually. Sophia, maybe you want to kind of share a little bit more about that kind of journey that Celo's been on to kind of move to the OP Stack in particular, and just sort of like where that kind of came from and sort of the steps so far in that journey.
Yeah, 100%. So for a bit of context, Celo is super old. We were in L1 way back when, and we originally launched as a proof of stake mechanism back when Ethereum was still proof of work. So one of the big reasons that Celo was launched was for carbon, because of carbon and energy. And the second one was because of lower gas fees. So those are the two things that we wanted for real world adoption and the reason Celo was launched. Now that's not really the case, right? With L2s, you can have very cheap gas fees, and Ethereum is now proof of stake. So with that, we're now settling on Ethereum, and we're transitioning right now from an L1 to an L2 migration, potentially, hopefully by the end of this year, hopefully by DevCon. So that's a big reason we transitioned over. And then OP specifically, that just worked best, one, with our tech stack, and two, with our values alignment. I think OP really exemplifies what it means, the extension of Ethereum and a lot of the values and the core values of with retro PGF and a lot of the other pieces that center this community and scale are centered around scaling Ethereum together. And so we're really excited about that mission and those goals, and excited to be part of that family.
Amazing. Yeah, super cool to hear. Yeah, I remember seeing the kind of original blog post come out about Celo kind of reaching out to the community that you have about the move to an L2, and just seeing how positive the response was for that. One of my highlights from the last year for sure. So super cool to see. Yeah, I mean, kind of, Ian, you are on kind of a different journey than that. Like you're not as old as Celo. You're kind of more of a recent project. I guess curious, like what has kind of led your team to kind of build. I mean, first of all, like World Chain, and then also like join the Superchain fully as well.
Yeah. So for WorldCoin, like the protocol itself, World ID, it canonically lives on Ethereum mainnet, but the Merkle roots can get bridged to many chains. So World ID itself doesn't live on a single chain. It can be used in many different places. But for our users in World app, there has to be a chain where all of that activity lives. And we'd used a couple different chains in the past, but last summer we migrated our users to Optimism mainnet. And at that point, we knew that we were planning to be a part of the Superchain. But we weren't at the point where we needed our own chain. The Superchain sort of concept and ethos was still really just beginning to come together. But we've hit the point now where having our own chain and being a part of that Superchain really makes sense. Last time I looked at the numbers, we were spending over half of the gas on Optimism mainnet. We subsidize the gas for every user action in World app. And that's a lot of gas, right? So on one hand, it's like we're sort of graduating from OP mainnet to our own OP stack chain, but we're also hitting the point simultaneously where like the Superchain is really solidifying from a concept into a thing that exists, right? We have interop coming soon, all those fun sort of things. So really the timing, everything worked out super, super well for us.
Gotcha. There we go. If I can unmute fast enough. Super cool. I mean, yeah, I remember when Optimism moved, or sorry, when WorldCoin moved to Optimism for especially all the safes that were deployed. I remember when that first started happening, people thought that somebody was trying to like DDoS the Optimism chain, and I remember that like I think DC Builder like went on Twitter and was like, oh no, that's just us. Sorry about that. No need to be worried here. So. Yeah, I remember that. The fact that you are, in some cases more than half of all gas flowing through the Optimism network is I think a testament to the amount of adoption that World App has seen, as well as like, yeah, it's probably time to graduate. So I think it makes a lot of sense. I guess as part of that graduation, you're going to be joining kind of the Superchain as well, and the Superchain's become much more well defined over the last year, as you mentioned. I guess like, what do you hope that means 1 year from today? Being part of the Superchain, what do you think that means for WorldCoin?
It means that we don't need everything on WorldChain, right? So that we can focus on like the absolute core things that we provide to our users and that they interact with on a daily basis, but users can interact with all of the other chains that are part of the superchain and the types of protocols and apps that they cater more towards without like the huge user experience downside of having to add a bunch of different chains to your wallet and try to figure out what chain you're on, how to get funds between chains, right? It really is like creating an ecosystem where you get to specialize in a lot of different things on different chains, and you get all of the benefits of those specialized chains without any of the downsides of them being different chains, and the scalability that comes with that too.
Totally. Yeah, I guess like in a way, like the benefit is, you get to tap into this whole ecosystem rather than, be solo out there on your own, and sort of be starting from scratch. You kind of tap into an already existing distribution of users and assets and networks, and yeah, it seems like a pretty good deal, I think, if you're a chain. I guess, Sophia, I think one of the things that a lot of people will be very curious about is, one of the things I also loved about this like Celo transition from like L1 to L2 was like it was super public. Like there was a lot of public conversations. Like it was all on the blog or on the forum. Sorry, there was actually bids from like other ecosystems to have Celo be a part of their ecosystem as well. Like it was super public. Like it was like really interesting, and like I highly recommend like anyone to just take a look. I mean, it's all still there. I guess like what has been, I know you kind of recently joined the team, but I guess what have been some of the things that you've like learned from the team on the difficulty of moving from, hey, like we were like an established L1 with like our own kind of like infrastructure stack to, now we're like an Ethereum L2. Like what have been some of the kind of high level difficulties in that transition?
Yeah, no, that's a great question. I will say I am new, so it's been like a month on the job. But I do think on the app layer, what's really exciting is there's a lot of new things that can be done with Cell 2. So just having native bridging is going to be a huge unlock. But the team we have a whole team. For anyone who's not familiar with our ecosystem, we have C Labs, which is just the engineering team fully focused on our protocol and on our blockchain. And they've been working super hard to get Dingo, which is our first testnet, launched. And so we did that right before ETH Global Brussels. And so that was a huge announcement we had at ETHCC there. And then there was tons of learnings about what that meant. And now we're updating our official testnet to be Alpha Horas 2, which is our new Alpha Horas testnet, but fully on an L2. And so we'll have lots of experimentation over this next few months about what that means. We're one of the first ever to actually migrate to an L2 from an L1 on Ethereum. And there's lots of exciting stuff in there, but we have a really great team that is pioneering a lot of this tech for the first time, and lots of exciting stuff when it comes to identity layer as well. I know WorldCoin does a lot with that, and Celo, specifically, one of our big identity layer pieces is we do transaction mapping with phone numbers rather than wallet addresses. So we have something over like 3 million phone numbers mapped to a wallet address that you can send transactions with. So this might be one of the largest identity layers in the whole industry as well, and that's natively on our blockchain. Lots of fun stuff with fee abstraction. You can pay with any gas fees, Celo, ETH, USDC, USDT, all of those fun stuff you can pay gas fees with as well. So a lot of fun features that are going to get brought in from our L1 onto our L2.
Totally, yeah. And there's a bunch of like really unique aspects of like the Celo ecosystem. Like it's focused on mobile, right? And I think that's highlighted by like the phone number focus. It's focused on like making it easy for people to use these networks, and like stablecoin gas is like such a cool unlock from my point of view. Like being able to like pay and hold like tokens that like don't move for like network fees, like huge unlock. I think it's cool to like see all those. I think it's both difficult to like bring all those functionalities that you've like baked into your own L1 and like bring that into the L2. But I mean, it's great, I think, to see that like the OP stack is flexible enough that like it can support some of these existing functionalities that you guys have.
And we can continue to be a core contributor to support as
Totally.
that as well.
Yeah, I was curious about that piece because, obviously like Cello has, like you mentioned, like C Labs, but there's also a huge foundation and like actually a very like active community in DAO. Like one of the aspects about building on the OP stack is like the OP stack upgrades themselves like come through optimism governance, right? So like, as like a delegate myself, like I remember voting on the proposal to like accept fraud proofs into the thing, and then that goes and upgrades into the OP stack. I guess curious about like how do you think that's going to play off each other if like Cello is building on the OP stack and then like the OP stack itself gets an upgrade, like like how will you coordinate those like network upgrades, or like how do you like make sure that like you're always up to date or moving in the right direction, or actually like building on the optimism stack, but like not necessarily like keeping up. I guess curious like how you think that's going to play out.
Yeah, that's a great question. And full answer is I'm not totally sure. I think we'll find out. One thing that's really exciting about Cello is because we're so old, we have a giant community governance system, of really active governance process as well, and ecosystem from that. And so I'm really excited to see how that begins to translate within the OP governance. I think there's a lot of people that are involved in both. And so that's going to be really fun. I think I slightly view like optimism as like if the United States, it's like DC, and then each place is like their own state, so they get a lot of control over how their own state navigates and make decisions around there and governance around all the policies that happen in your own state. But then you also have a shared governance altogether about things that might affect everyone. And so I'm really excited how that's going to translate into the next year and how we're all going to work together to scale Ethereum together and scale on-chain adoption for the world. But I don't know exactly logistically
Totally.
all of that quite yet. So we'll see.
Yeah, makes sense. Yeah, I mean, it's up to the people. And like I said, like I think one of the things that I thought was like some of the most heartwarming thing I saw in a long time was like how much the existing Cello community was excited about like this transition. And like, so I think you're going into it with like a lot of goodwill from the community and excitement. So I think that's super helpful too. I guess for Ian, we mentioned some of the cool features that Cello has that already exist on its L1 and kind of like bringing over to the L2 side. I guess maybe can you highlight some of the kind of unique aspects that you can now do on like World Chain, and like how are you kind of thinking about now that you transitioned to your own chain and you have a little bit more control over like the rails that things are running on, like how are you thinking about some of the new features that you can kind of port into that chain as well?
Yeah, so to be clear, we haven't migrated to World Chain yet. We're currently in a gated access developer preview. So our partners, protocols we rely on can all deploy before we migrate all of our users over to the new chain. But with that, there's two main things that we want to implement on World Chain that make it the best blockchain like for real humans. One of those is that for users who are verified with World ID, they can get a certain amount of gas for free at the chain level, right? Not just us subsidizing that through Wallet app or through World app, right? That you can interact with whatever protocols or dApps you would like, and you can use potentially even other wallets. You might be able to do this for your ledger and still get a reasonable amount of gas subsidized for free, but in a way that we know, like you as a real human can only get so much gas for free, right? We're not going to let you DDoS the chain because you're a real human. And then the other thing that ties in with that is transaction priority, right? We'll have like a VIP line for transactions when building blocks that will prioritize transactions coming from real humans. And the big unlock that these two bring, as I see it, is that we're solving two of the most like frustrating friction points for users, especially those who are new to blockchain, right? We've all had that moment where we ask ourselves, like, what is gas? Why do I need money in my wallet to do things? How do I get that money into my wallet in the first place? And we can just make that a non-issue. And similarly, we've all had that moment of, okay, I sent my transaction. Why is it taking half an hour to be processed, right? Why do I see it pending on the block explorer for so long. And again, we can just make that not a problem, right? If there is like some massive NFT mint, for example, you as a real human aren't going to have to compete with bots to try and get your transaction to go through first, right? You just get that priority for being a real human. And that's something I'm really, really excited about, solving those user experience perspectives for our users, many of whom are completely new to crypto or even the concept of like digital money, creates a much better space for them to explore and try new apps.
Gotcha. Yeah, I think it makes perfect sense. I mean, there's like you said, there's so many of these like friction points in which like you are basically treated as an equal to anyone trying to access the network, right? And I think we know that like if you just look at Ethereum, like top gas users, like half of them are tagged like mevbot, right? Like we know that like a lot of the heavy use of the chains are arbitrage opportunities or like movement of funds in some way that is like not being done by like a human hitting OK on MetaMask, right, or something like that, right? So yeah, I think it makes like perfect sense that like when I'm a human showing up to the door, like I should be treated a little bit differently than a bot, right? I guess curious about like joining the Superchain is also sort of like joining a kind of world of an ecosystem of like interoperable chains, and you've chatted a lot about how like World ID is going to like impact transactions on World Chain, but I guess curious about like how do you see World ID like having an impact on like the rest of the Superchain ecosystem?
Yeah. So not to try to one up Sophia, because we love Celo and everything they're doing. Our identity layer has a few more real people on it. We've now got over 6.3 or 6.4 million people verified at the orb. And a lot of their activity will live like natively on World Chain through World App. But as I said at the beginning, like World ID is very easy to bridge to new chains. But the cross-chain interoperability of the Superchain will only make that even easier to use for applications on other chains, right? If we don't need to make sure that we're bridging these routes to every single chain from ETH mainnet, right? That saves on expense and complexity. And, similarly, like for our users, it means that we don't need to do things like try and get a ton of liquidity for different like swap pairs on World Chain when they can go and do those sorts of swaps on another chain that might have better liquidity for that pair. It really is just like I see the interop portion of the Superchain to sort of add on to that like US government where you have the federal government and the state government, right? Interoperability is sort of like the interstate highway system. It's what makes that like commerce and compatibility between all these different states way more effective and way more fair and sort of democratized because it's coming from that highest level of government. I think it's really like the biggest unlock for blockchain that I can think of right now.
Totally. I'm loving this US government's analogies. I wonder who's Eisenhower in this case, who's like paving all the roads. Super cool. I wanted to ask Sophia, I mean, you had this really unique experience where like also you were working on Public Goods Network and the chain that was part of the Superchain that was also kind of part of the GitHub or the Gitcoin ecosystem. I guess curious about what kind of learnings are you taking from the experience on Public Good Network and applying them now that you're working on Celo and kind of building on the OP stack once again?
100%. So yeah, this is super fun because I come from PGN, and PGN, for a bit of context, was one of the very first super chains alongside Base, Zora, Mode back in July of last year of 2024. And so we had, 2023, funny enough.
Yep.
So we had tons of learnings. I think one thing that made PGN really clear and unique is we had an ecosystem from the get-go that wanted to use PGN. And so it was very targeted and very clear about what our value prop was as a chain and who are the types of apps that we were targeting. So it's specifically on-chain funding apps because these apps tend to also be public goods in themselves. And so for them, they struggle at being able to monetize their own business. And so having a chain that can unite all of them, just as they're being used, creates a business model for a lot of these apps. And so it was really clear coming in with an ecosystem about who our chain's for. And my entire focus at PGN was very specific and narrowed. It's how can I get the infrastructure for these specific apps, like these 5 target apps that want to use PGN? How do we make sure that our chain is built for them? Obviously, Celo is on a total different scale. PGN had a team of 3, and Celo has a ecosystem of over 1,000. And so it is a whole different scale, but I do come into it very similarly of who do we expect to be the people that are using our chain, and how can we ensure that everything from technical details to narrative positioning to the apps that we support to our community initiatives, how is everything aligned based off of the users who will actually be using our chain, and why do they need to use our chain? So like I mentioned before, with phone numbers, low fees, fee abstraction, and then mobile, we're able to target a lot of users who don't even know they're using blockchain. They're very non-crypto native users, and they use it a ton for stablecoin payments and get to do it straight on their phones. And so we're very targeted about who are the people that we're trying to build for. And I think that's what makes it really strong as we come in to like a bunch of other chains supporting the scaling of Ethereum on OP Stack. Each chain has their niche, and we can support each other out in that way.
Yeah, I love it. And I think that's like super like helpful for builders too. Like as they think about like what kind of problems do I want to like be solving in the world as a builder, and like where are the right places for me as a builder to like actually deploy those solutions, I guess. Like as you mentioned, like kind of all the chains have their own like niche or existing community or like set of users that are like more like well defined. And I think that like it really helpful as a builder to be like considering like where is that distribution for me as somebody like building, and what can I do there.
100%.
Maybe just kind of as a wrapping up question, kind of similar question to you, Ian. I mean, as you mentioned, World Chain is not live yet. It's like a test net. It's like starting to kind of like happen. I guess like what are you excited to see as like the first killer apps on World Chain, and just like playing around with the different primitives that you guys are establishing?
I mean, I think our first killer app will be World App, but that's a little bit
Fair
of a
enough.
self-serving comment. But for us, when it comes to like what we want to see on World Chain, we're actually very unopinionated about that, right? We want to see things that are meant to be used by real humans, right? We're not trying to prioritize, like DeFi protocols around getting the highest yield or staking, right? If it's a product that leverages those sorts of protocols to provide, like a much more sort of savings style interface to a real user, that makes a lot of sense to us. But we're not trying to be here for like the most degen people in Web3. We're trying to make a space for real people who might not be familiar with blockchain to just get to see what's there, right? And I think that's like aligned with Celo in a lot of ways, right? You have much more like very specific use cases of what you see your users using. For us, I think it's sort of this open call to the industry to build things with humans first in mind.
Yeah, I love that.
I love it too. I mean, I think, like you said, Ian, I think both Stello and WorldCoin represent a focus on people and building for real people and solving real problems. And from the whole presentation, having things set up around like interoperability coming through the Superchain ecosystem soon, having safety first with fault proofs. Like, I think so many of these pieces are like starting to like align that like you can really build for the user. And yeah, I'm excited to see that, both Celo and WorldCoin are joining this ecosystem in their own ways and being a part of what's happening here and bringing that human focus to the network. So yeah, thank you both for your time today and for sharing what you guys are both doing.
No, thank you so much for having us.
Awesome. Well, thank you both. And yeah, with that chat being done, that does wrap up the Superhack Summit for the Superchain chat. So thank you everybody for joining us today and for being a part of the Watchers. As a quick reminder, submissions are now open for Superhack. So for everybody who's been building over the last week or so, you can now go onto your dashboard and start filling out your submission. You can edit your submission up until the deadline. So I do recommend going on there now, creating your project if you haven't already, starting to fill things out about what you've been doing throughout the last week, and get ready for that submission at 12 p.m. Eastern time on the 11th. So that's Sunday, 12 p.m. Eastern time. That's when submissions are due. So make sure that you start working on your submission now, start creating your video for your submission as well, as that does take more time than you might expect, and head onto your dashboard and hit submit. So really looking forward to seeing all the great projects built over the last 10 days. And best of luck as you wrap up all of your projects. And thank you again for joining us for the summit. Cheers, everybody.